Okay, so now let's go ahead and assign the flow series to our boundary conditions or boundary cells. So in order to do that, there are several ways to do that. Maybe I'll show you a different method tomorrow. I'll just use it right from here. Make sure to be on the boundary conditions and feel free to raise hand if you're not following and if I'm going too fast. Click on enable edit. Now let's go to this upstream flow and click on that cell. That cell, it should be I of 3 and J of 42. If you click on any cell, it will give you the information of that particular cell. So it will give time, L index, I and J index, and what is the X and Y coordinates, DXTY, bottom valuation, depth, and it's really helpful to diagnose when you are using it for so long time to see what was the issue in your model. Now let's go ahead and right click here and click on edit. Remember, we use new in order to create a new boundary. Now we want to edit. Click on edit. So all of you should have this form. In order to assign the flow, click on edit there. Then it would have, if you haven't done it before, it would be 0 for you. Click assign number of series as 3 and hit enter. Then it will create 3 series for us. And let's go to the first series, current series of 1, and I named the current series as upstream. It's helpful because on the drop down menu in the main window, it's easier to select which series is which if you name your series. So go ahead and enter 200 space 2.832. That's the data. At 200 time you have the flow of 2.832, and at 220 you have the flow of 2.832 again. So it's a constant flow. Okay, everyone done this so far? Next we want to specify the east branch. Go to current series. In order to go to second series, you just click here this up down button here on the top. I'll just select there 2 and then hit enter. It will say series 2. I want to name it east branch. As I mentioned earlier, it doesn't have any flow, but we're still going to include it for the sake of completion. 200 to 220. So essentially including east branch doesn't make any difference to our model. Just wanted to show you how you can import the data, import the numbers. However, if you have the real data, you could just change this boundary and it will start interacting with the model. Okay, let's go to the third series. Click on the arrow and go to the third where it says series underscore 03. Now let's name wastewater treatment plant, WWTP, and the flow that we are going to use is 0.33. These numbers have to be exact because when you are trying to compare to the analytical solution, if it's different, then your results may not look lined up with the analytical. All of our boundaries, if you are interested, you can see the series how they look like. If you click on view series, the more button next to the current, if you click on more here, then it will show all series button, right? All of you saw this. Now let's go ahead and click on show all series. Then it will pop up this smaller button window where it shows there were 3 series and you have to provide the labels. I think that's a bug, it's not displaying it properly. But so the value here 0 means it will not be used. If you want to use these boundary conditions to plot, just write 1 or any values greater than 0. Make 1 to all of these. Everyone following so far, right? After you have put 1 value to each of these boundaries, let's go ahead and click OK. It will always ask what is the time series start and end time series. Right now we have data from 200 to 220. I mean, we haven't assigned what time we want to run yet, so I'm not going to click that. Click OK. So now you have three series, but you can see only two lines because one series didn't have any data. So if you change your y-axis, if you move it up and down, then you can see your all the three axes. Let's go ahead and change these axis labels. Right click next to your y-axis, go to bounds. You can do it later, I'm just showing you for display purposes. I want to show all the boundary conditions here. 0.6 to 3, I'll see all the series. So here it starts from 200 to 220. I have three lines. If you want to change the color, if you want to change the thickness, you can right click on this legend. Right clicking on legend will take you to line options and controls where you can select your thickness of each cells. We can do it later when we are doing calibration. Just wanted to show you can see all the series at once and see if it's right or not. If you look here closely, there are boundary condition group and concentration tables, and you have flows, you have a series. This is just right click on this boundary and go to edit. This is the main form. Okay, you're here. So there are things you need to understand. If you have only constant flows, if we could have used this on this simple example, but I wanted to use series, so this is how you will be ending up using in your real model. But if you just wanted to use flow, you could just specify here constant flow like 2.832 and assign the concentration and be done for this simple cases. But we want a generic example that you can build on to make a complex example. So now that we have assigned our flows, if you click on this drop down, you have three series. Not sure why my second series is not updated. Same thing.
The name is, yeah, I changed the name, but it changed back to 123.
Really?
Series, yeah. I don't know. It's not saved. The number is there, but the name of the series.
Okay, so if you have done it the way I did it, the first one is your upstream. That's why I always like to name it. So if you had 30 or 40, it would be really difficult.
Can I ask why each branch is a 0 in terms of flow rate, since it's not contributing to this?
Yeah, for this example, just added another extra boundary.
Okay.
I mean, next time, I mean, we could delete it completely. This is just to show if you don't have data, it doesn't have impact on your results. Okay, it's working. So make sure you are on this upstream, right click, edit, then we'll assign flow assignment, click on drop down and click on check upstream. So this means this particular cell has been assigned that upstream's time series, so it will use that time series as a boundary condition when it's going to run the model. Okay, let's go click OK. Now let's go to east branch inflow, edit. It's the same form. Now this is the east branch. Let's go ahead and check east branch from the drop down, so we have the right flow. Click OK. Now let's go to wastewater, click on edit. It's the same thing, just change your flow table to wastewater treatment plant. Click OK. Click OK. Everyone done that so far? So now let's go to downstream. We haven't assigned time series to downstream yet, right? We have done it for upstream. Why is that? There's some bug. Click on the downstream cell, right click, click on edit. So the major difference between upstream and the flow boundary and downstream is here you have two different options. You have either pressure means water surface elevation, or you have harmonic. So if you're going to deal with tides, EE allows you to have option to specify what are the harmonic constituents you want to use, and based on that harmonic constituents it will create a time series for you. So that's out of scope for now, but it's a really handy tool. Let's go ahead and assign a pressure series to our boundary that we have not done so. Click on E, edit. Here next to the pressure, click on E. It says data series water surface. Since we're going to have only one series at the downstream, click 1 and hit enter. And I will rename this series 1 to downstream. Time again 200 to the water level we're going to use is 301. Constant water surface elevation means whatever flow coming from upstream it will just let the water go out of the system. 200 to 220. Okay, so if you are dealing with a harmonic boundary it can, okay, again it's you can view all the series, you can view, um, click OK and then it's straight line, nothing to view here. But if it was a hydrograph you could see it changing with time. That's really helpful. um, Now that we have assigned that boundary series, let's go ahead and click drop down and check this downstream. Click OK. So I think we should be able to run the model with, now we have assigned initial conditions, we have assigned boundary conditions. Now we need to assign what time period we need to run. We haven't told EFTC model yet. It wouldn't automatically recognize what's the time. So in order to do that, let's go ahead and click on timing and linkage. So under model run timing, we're going to change our time of start to 200 days. So here the reference period means what is the number of the reference period would again depend on the duration of reference period. So if our reference period is say 24 hours, that would be in days. So starting time is 200. If you want to run for 20 days and you put your duration of reference period to 24, then it would be 20. However, if you have your duration of reference period as 1 hour, then it would be 20 times 24 would be your reference period. So I usually prefer using duration of reference period as 24 hours, so it's easier to deal with what is your starting and ending time. I will just add this and this and we'll get the ending time. And when you're running a model, it's a good idea to have your beginning date and time. So what it does is when you are calculating a Julian date for your actual date, then it will use that base date to calculate the Julian date. Let's go ahead and use 2017 1 it's already there. It doesn't matter which one we are using for this example. Time step, we are going to use 100 seconds for this. So the time step, you always have to check whether you might want to go as bigger as possible without without disrupting the CFL condition. CFL is Grant Levy Friedrich condition. Um, so that's a very important factor in these kind of hydrodynamic studies. So dynamic time step, we talked a lot about this in the afternoon, say in the morning session. So if you want to use dynamic time step, you have to change the value other than 0, and you might want to put it low so that it's stable and water surface elevation are not changing so much. So for this example, we're just going to use a constant time step. That will be 100 seconds. So I'm not going to touch about these options. We'll come over these and tomorrow and next several days. Beginning date. Now let's go to the next tab that says EFDC Explorer Linkage. So what does Linkage do? What Linkage does is it's required for post-processing, and when you run the model, how often you want to write the snapshots or results to your output files. So by default it says 1440 minutes. That it's very so we want to trim it down to 15 minutes. So we want to export our output every 15 minutes. Let's go ahead and change to 15 minutes. So if you had a rooted plant and epified model, you would use this. Another option I want to point out here, maybe I'll come back later.
This 50 minutes compared to the original 1000.
Yeah, it's way.
So that will give us a much more bigger output files.
Yeah, yeah. Your output file will be depending on how often you write your output frequency.
Yeah, those files get really big.
Yeah.
Does this have something to do with the total computation time?
Right.
Yeah. Okay.
Yeah. Every time you change these numbers, yeah, the code has to go in, open the file, then write, then close. So it will take a computational burden. So here it would depend on what type of data you have to compare with. So let's say you have monthly data and 1 point each month, then you don't have to output it every 15 minutes or so.
So if the model's running really slow and you don't need that high,
Yeah.
you could check that number and see if it's
Yeah.
running too much. Okay.
Right. So
That's really
it did, and if you are, for example, you have to run 3 years, but
Mhm.
you are only interested in couple months where you need high frequency data, right?
Mhm.
So you could do that by coming over here. So high frequency dates does that for you. If you click on domain, so it will change everything for all the cells. I'm just going to show options. I'm not going to use it, just showing you how to use it. Okay, but it's really useful and it will save you a lot of time.
So
Yeah.
it means you can change for different time period. You define
Yeah.
the frequency.
Right
Oh,
here.
that's huge.
Oh,
Let-
okay. So
That's so
say
good.
I'm interested in only January, so I can put like January, the Julian date here, right?
Yeah, let's say we are not running for January because we are running from 200 to 220. Let's say I'm interested only in 202 days, right?
Oh.
Let's put a 202 on Julian and hit enter. It will automatically pull the date based on the date we have provided before. So the base date is important. That's what I said earlier. So what is the duration you want to output this data? Let's say 24 hours, right?
Yeah, like I'm interested in. I mean, my interest is only when it's 202 days.
Right.
Yeah, and
But it starts from 202 days to calculate the high frequency. But how far do you want to go? You want to go 1 hour, 2 hour, 3 hour?
Duration.
Yeah, duration. You have to specify. Let's say 24. So
also
it
in one day.
so it will have high frequency output for that particular day, but for the rest of the days, it will still have the same output that I have defined before. So it's a really handy tool if you, for example, you're comparing vertical profiles
Right.
and
You only have like
yeah,
10 dates for
10
an entire
days,
year.
10
Yeah.
periods. You can output like every hour or 2 hours for the
Yeah.
particular regions, and rest of the times
That's what
output
that's-
3 hours, 4
Wow,
hours.
that will save a lot of
I
time.
have one
Holy
question about
cow.
the input of boundary time series. There's always, I mean, the default FDC utilize Julian date.
Yeah.
We are not using like the
No.
But we could here get a start date just want to match the observed time series, or I don't know what's the purpose
So-
of
so here-
the start date.
Yeah.
Why
So EFDC Explorer, you can specify the real date in your observed data
just for
the calibration. It doesn't have to be on
calibration.
Julian. It
Mainly
can be
for
a
the display purpose, not for the model calculation.
model calculation. It will use Julian.
Julian date.
Yeah. So the only reason it's here because we want to make sure it's the right date.
Okay.
even if it's Julian, but when we are displaying results, we want to show it on the regular date
But
format,
for time
right?
series input file, we still need to convert to Julian.
Mm-hmm. Yeah.
Okay.
So that's the first thing I would do. If I have a data, I always have a date time stamp,
Yeah.
and then I have a hydrograph values. And first thing I will just convert to Julian date based on the first starting year, and then I have a time series of Julian date versus the data.
Yeah. Okay.
Then I will import it into EFTC Explorer. Let's say this frequency I want to 1 minute. Click OK. Then it will output the data for those period to every minute. It will slow down a little bit, but this is a very small model. It won't have much impact. So another option to output is cells. Domain does it for all the cells, but if you want only particular cells, let's say you have 10 cells where you have vertical profiles, right? Then you can say how many high frequency groups you want to have, and then you can specify your X and Y coordinate for that particular cell and just give a name to that cell. That's how you output high frequency data for only those particular cells. So I'm not going to go over here. On the bottom here it says get I and J. Usually you don't know what is your X and Y, so if you have I and J, it will convert X and Y for those coordinates for those cells. So just wanted to point out there are options that you can take advantage. If you don't have to write every time step, you can use it. I think we are ready to run. Let's go ahead and save it. We haven't assigned any dye concentration yet. I just want to make sure it's running first before adding a dye component to the model. Let's go ahead and run. So in order to run, so if something is missing, it will give us information. Let's hope one of us made a mistake. Run EFTC explore, run EFTC. Here I have a maximum of 8. I'll just use 4. Not necessarily it will give me higher speed, but since I'm running only one model, I want to choose as bigger number as possible. It's usually half the maximum you are using, so it's using only every second thread to do the calculation. KMP offset is necessary when you are running multiple models. Let's say I have a 8-thread machine. I want to run 2 models concurrently at the same time, and I want to make sure each executable is using the same threads each time. So I want to use first two threads for one model and second 2 threads for another model. Then I would use KMP offset of 2 for the second model. For the first model, I'll still use 0. That's fine. So print interval is how often you want to print your output on the executable window. I mean, it wouldn't take much time, but if you don't want to look at every time step or every few iterations, I would just change to 500. But for this example, I'll just keep 50. Here again, you can at the last minute you decide, oh, I want 30-minute linkage frequency, then you can change it here as well. This is the runtime INJ that I showed before in the cell map, where you could right click and show which cell you want to output. You can change it here again also. So if you have your calibration settings, then you can and this would be active. If you had a calibration settings, then it would, you can tell EFTC Explorer to run all the models and do all the calibration, plot everything and calculate the statistics. At the end of the model, it will do everything for you. So you just need to make sure to click here.
So what is the type 3?
Runtime, this one?
Go there.
Oh, type 3 is, it means if you hover over here, it means the dye concentration. By default is 3. So if it has any constituent transport, it will show the value for that. But this is just the flow, so it wouldn't matter whatever you choose there. Okay. Again, these are only for display purposes while running. Now let's go ahead and click run EFTC and see what it happens. What happens?
I got your message.
It's stuck here. Hopefully, is it running? Time is start. Okay, it's started. I will pause it. Okay. So if you pause your model, if you hit space or any other button, it will pause your model. Then you can go back to your model and review results and see if it's making sense. I mean, it's too early now, but you can, let's say you run it for 1 hour. So how to find out if you run your model for 1 hour? So on the left here it says time in days 200.001. It's because our times, and this is the time in days, and if you have this values up to 201, then you know that the model ran for 1 day. And at the, let me run for a few iterations, and then every time step, every 10 or 15 iteration, it will give you what is the estimated time to finish. So here it says estimated time to completion is 0.28 hours. I mean, it will change for the next few iterations, but it will give you overall idea like how long it will take for your model to run. So if you have a really small time step on your big model, it might be 200 300 days at first, then it will slightly trim down, but it will roughly stay same after 10 or 15 minutes. And then that's the point you want to decide whether you want to run that model or you want to change something and come back to it. So this information is really helpful. Pause your model, just point on any, just click on any other button than the space or whatever key you chose. I'll choose 5. So if you choose the same button to pause and unpause, it will just the model will just stop. Make sure to use different key when you're pausing and unpausing your model. I'll just kill this program and then we'll assign die concentration. We just wanted to make sure our program was running. Okay, so in order to just kill it, just press pause and then again on pause with the same button, then it will kill our program. Okay, so now our model, you can take a seat.
No, don't worry, I can start.
Okay, so we have successfully run our model for hydro, right? So this morning I said like first make sure hydro is running before adding any complexity. Now let's go ahead and add a die module to our program. In order to do that, go to active modules on the fourth tab on the left and click on activate die. So now let's go to die module and initial conditions. First we have to assign the initial conditions. Initial condition will have 0 die concentration everywhere, so let's go ahead and click on die, and we're going to use a constant value. Click on use constant, use operator 0. We have only one layers, so if you have multiple layers, you will have to choose this if you were to use the constant value for all the layers, but this time we don't have to worry about it because we just have one layer. Let's go ahead and click apply. I mean, if you want to specify 0, it's like even if you don't specify, it would take it 0. Just wanted to show you how to specify these numbers. After you hit apply, click done. Let's go ahead and see if actually oh, because I have a model run, let's go ahead and save it as a different model. You haven't saved it yet, right? Go to save project and go to your root folder, double click on the folder. I have the root folder as 2017 Edmonds, so I would create a new model, hydro die, because I have activated die and I don't want to mess up with the results that I had for hydro. So every time you change something, new parameters, you might want to save it as a different model. Click OK. Okay, hopefully it will work now. Now let's go to our viewing options. So in order to view die, Go to water by layer, viewing option, choose water by layer, and on the options there are several grayed out options like salinity, temperature. Click on other, and the first option would be dye. So we have our initial condition at 0 dye concentration. That's what we wanted to achieve, and we have done that. Let's go ahead and close it. Now I'll show you a different place where you can assign the boundary conditions also. Let's go to this domain tab here, the third tab from the left. Click on domain, and there are 4 tabs. Click on boundary conditions. Okay, this form alone has so many fields. All the input, all the boundary series that you import into your model can be accessed directly from um, these fields here. If you have flow, for example flow, you can see the number is 3. That means you have 3 time series assigned as a flow. And for water level you had 1, right? And now let's go ahead and look our first. Let's assign dye concentration from here. So dye E has only 1, it has 0, so we'll assign dye from here. We'll assign 3 concentrations, 3 time series for dye. One is upstream, wastewater treatment plant, and east branch. Let's go ahead and write number of series as 3. It will create 3 series for us. Let's name upstream dye or whatever. So the concentration what we want to use is, for the upstream we are going to use a dye concentration of 0.2 milligrams per liter, 200 0.2, and 220 0.2. Okay, so that's the concentration we're going to use on our upstream. Next, what we're going to do is, everyone on the same page so far? Let's go to our second series and assign as east branch. We'll use the same concentration of 0.2 for east branch. So it's 200 space 0.2, 220 space 0.2. So we have a constant dye concentration from 200 to 220. Finally, the third would be wastewater treatment plant. Go to your current series 3 and assign double wastewater treatment plant. The value we are going to use is 15 milligrams per liter for wastewater treatment plants. We want to see the impact of wastewater treatment plant into our model domain, so we have a higher dye concentration. Let's say 200, 15, 220, 15. This is just like repeating the same thing. Now click OK. Now we have assigned 3 dye series, but we have not connected to the actual boundary files. Let's go ahead and do that. We go to the boundary group utilities on the same tab, boundary conditions, and click on edit review, showing you different locations so you can access the same information. So here you can see all the 4 boundaries that we have assigned. One is downstream, it shows boundary type open south. Second is east branch, flow, upstream, wastewater treatment plant. Now let's go to east branch because that's first on mine. Edit, go to edit. It would take us to the same form that we would get under view plan if you hit right click and edit there. So now what we want to do is, look here, concentration tables, and if you have time series, if it's changing with time, then we have to use these series. But if it is constant in time, for example it's always coming 0.2, which is the case in our example, we could have used this form or this form, but I want to use this form because this will be the one that we will be using more often. Now let's click on drop down next to dye and find our appropriate dye concentration series. It's east branch. make sure to use the same time series for that boundary. So I usually give the same name for the flows and boundary names, so it's easier to select. Click OK. So we have assigned. If you click on east branch, now you can see it says the name is the flow table that's been assigned is east branch, and the die is east branch, and it starts from our starting to the end time. So if you're not sure which time series that you assign to which boundary, it's easier way to see is just click here and look at on the right hand side. You will see all the information. Go to upstream. Let's do the same thing. Assign the upstream die to the die concentration. Click OK. We have assigned die concentration there. Then finally, wastewater treatment plant. Go to edit, die. Oh, drop down wastewater treatment plant. Okay. So we have assigned now the die concentration to our boundary conditions, right? So we have assigned initial conditions, we have assigned boundary conditions. Now we are ready to run the model. Just want to make sure everything's right. So now you can make a comment about this model run. Hydro die based on Hydro 1. This model was based on Hydro 1. The only thing I added was added die component. So this is how you distinguish between the previous run and this run, just even looking at this information. So let's go ahead and save it. Okay. Let's go ahead and run it now. To run the model, go to the same button on the top that says EFTC with the play button. I'll run the model now and see if it runs faster.